Hey everyone, it's Bradley Bush with another algebra video for you. Today we're talking about the top 5 useful formulas for the equation of a line. If this is your first time to my channel, thanks for coming. I'm glad you're here and I hope you like it. If you do, please consider subscribing, hit the like button, or leave a comment. Here they are. Top 5 most useful formulas, I think, for the equation of a line. Let's discuss them. Let's go with the number 5 first. So number 5, the general form of the equation of a line. We have ax plus by plus c equals 0. So in other words, everything in the equation is on one side of the equation and 0 is on the other side of the equation. That's really the defining characteristic of the general form. A, b, and c are just constants. And I can give you an example. Say we do something like 3x minus 4y plus 5 equals 0. That's how an equation of a line would look if it happens to be in general form. 3 is a, b is -4, and c is 5. That isn't the most useful form of the equation of a line. For example, you can't see the y-intercept or the slope from this equation here. But you'll see that in equations that I think are up the list a little bit. But it's still a valid and useful form, and you see it fairly often in algebra classes. Let's move on to number 4, the fourth useful, I think, in our list, the vertical line. So a vertical line, the way you write a vertical line is x equals and then some constant. So for example, you could say x equals 5. So this could be confusing because sometimes people look at a point, and a point has an xy coordinate, and they think that x equals 5 here in this vertical line. They think that that x is just the x coordinate, but really it's the whole equation of the line. When you just have a vertical line, you don't have any y in the formula. You literally just write x equals 5, and that would be a graph of a function that had 1, 2, 3, 4, 5. Here's 5, and then here's your vertical line at x equals 5. That would be your equation of a line, x equals 5. The next up the line, number 3, would be the horizontal line. So one more comment on vertical lines. Vertical lines aren't functions, so we don't see them as often because they fail the vertical line test. But horizontal lines are functions. So if we go to a horizontal line, we don't have x's in our horizontal line. We just have y equals and then whatever the constant is. Sometimes you'll see f of x equals a constant. It's the same thing. But if I, for example, had y equals 3, and I happen to be graphing this, and I had 1, 2, 3, there's 3, that's on the x, take that back, 1, 2, 3, there's x, there's 3 on the y, and here's y equals 3. So every point on the line has the same y coordinate, which is 3, and that's the equation of a line. It has a slope 0, it's perfectly horizontal. Let's move on to number 2 in our list. We're quickly moving up to number 1 here. Number 2 is the slope-intercept form. You use this all of the time, right? This is I think, one of the most informative forms of the equation of a line, because y equals mx plus b, that's the equation, that's the slope-intercept form. M is the slope, so you literally can just read off the slope from the equation, and the y-intercept is the b, and your y-intercept is 0 comma b. So if you had an equation, so let me give you an example. So say you had y equals -3x plus 4. You literally could read off the slope and the y-intercept from this. So the slope would be -3, and your y-intercept would be 0 comma 4. So I think the slope-intercept form is super, super helpful. It's it's almost, well, it fights for the number one place. It isn't used as much, but if you know how to use it, it could totally replace the number one here. Tell me what you think, actually, if you think 1 and 2 should be switched in the comments. I'm totally open to discussion here. But the number one useful formula for lines, I think, is the point slope form. And that is y minus y1 equals m times the quantity x minus x1. Your slope is m. That goes into the m spot. And your point, so you're given a point. So say this is used, for example, to find the equation of line if you are given a point and a slope. And the point, you plug in for the x1, y1. And the slope, you plug in for m. And then you generally solve for y to put it in the form of number 2, y equals mx plus b. But anytime you need the equation of a line, if you have one point and you have a slope, you can always find the equation of that line using the point slope form. So let me give you an example quickly. So say my slope is 3 and my point is 2, negative 5. If I plug this in, then I would say, I would go y minus, and then my y1 is negative 5 equals, and then I have 3 for my slope, and I have x minus, what's my x value for my point? 2, and the minus and the minus on the left give me a positive, so y plus 5 equals 3 times x minus 2. So that is in point slope form. Oftentimes, you don't stop here if you're doing this for a problem. Oftentimes, you would distribute the 3 through, and you would simplify, take the 5 over from the left to the right, and so you'd solve for y, and then simplify. So you would put it into the form y equals mx plus b most often. But you have the equation of a line, and you can do it just by by being given the slope and the y-intercept. Sorry, the slope and a point, any point. One last thing I wanted to mention was that you can easily go between the forms 5, for number 5, the equation here, the general form, the number 2, the slope-intercept, and 1, the point slope. These are all equations of lines, 1, 2, and 5. Those are all equivalent. They're just rearranged. Some of them give you more information than others. Some of them are easier to use in certain circumstances than others, but they're all equivalent. So if you have number 5 and you want to get to number 2, for example, you would just solve for y. If you had number 1 and you were in the form that I show you here, that I just circled in pink, and you wanted to get to 5, you would just simplify and then take everything to the left side of the equation and have 0 on the right, and you'd be in general form. If you were at the point slope form and for some weird reason you wanted to go to general form, again, you just take everything. You'd have y equals negative 3x plus 4, for example. You take everything to the left or take the y to the right, so everything's on one side and 0's on the other side, and you'd be in general form. So 1, 2, and 5, those are all equivalent forms, but you use them in different circumstances, and they all have advantages. Even though, if I'm being honest, 2 is my favorite. All right, hope that helps. Hope you have a great day. Thanks for watching, and have fun mathing.